Hey everybody, it's Mr. Carr again. Today we're going to be looking at 5.4 day 3. Okay, we're multiplying and dividing our radical expressions. So what we're going to be doing here is applying our radical properties along with a problem that looks like this. Looks very similar to some other binomials that you multiplied before, and that's because we're going to do the same thing. We are going to distribute here. So you can do this in any way you want. So you can take this and like kind of do the rainbow or claw idea, but you have to make sure you multiply all four items together. Personally, I'm going to do a box method. So when I do that, I've got a 2 by 2 box, so it's going to be 4 radical 3, and a positive 5 radical 2, 3 radical 2, and then a negative 6. So when I multiply these, I've got 4 times 3 is 12, and then root 3 times root 2 is going to give me root 6. 5 times 3 is 15. Root 2 times root 2 is going to give me 2 here. Okay, so that becomes then, this box right here will actually become 30 when I put that together, or when I multiply it out. 4 times a negative 6 is a negative 24. Radical 3 stays the same. Then negative 6 times 5 is a negative 30. Radical 2. From here, I just have to combine my like terms, which actually is nothing. So that means my expression here is going to equal to 12 radical 6 minus 24 radical 3 minus 30 radical 2 plus 30. Okay, so again, we're just using our properties there. We can't combine any of these because none of them are the same radical. If it was like 12 radical 6 and negative 24 radical 6, those go together. But where it is now, they do not. Okay, so I got another multiplication one here. So this one's a little bit special. So what's going to happen is I'm still going to go right to my box method. I've got 7 radical 2, negative 3 radical 3, 7 radical 2, and positive 3 radical 3. Notice all the same numbers, but opposite signs. So 7 times 7 is 49. And then root 2 times root 2 is 2. So this turns into a 98. Okay. Here I've got 7 times a negative 3 is a negative 21. Root 2 times root 3 is a root 6. Here I've got 7 times 3 is a positive 21. And then same thing, root 2 and root 3 makes a root 6. And then my last one is negative root 3 times 3 is a negative 9. Root 3 times 3 is 3. So this becomes a negative 27 when I put those together. When we look at this, we do have like terms, and watch what happens. Negative 21 and positive 21 cancel each other out. So all I have left here is going to be 98 minus 27. So my final answer is 71. Okay. That is actually an example, like when you notice like we have our same numbers but opposite signs. This is called, okay, sorry about that. So what we were finding there is actually called the conjugate. Conjugate is the same exact values, but opposite signs. So we keep the radicals of the same numbers, and they just have to switch their signs from a positive to a negative or vice versa. When we want to simplify a radical expression like this, that's in a fraction, we want to do the same thing. We have to multiply by the conjugate to the denominator. Okay, so when we simplify this, we're not going to get any decimal numbers here. We're going to get an exact value. So if I have root 5 minus 1 in my denominator, my conjugate is going to be root 5 plus 1. So it's the same thing, but opposite signs. Okay, but I have to do the same thing to the numerator when I do this. Now, here's why this works. It kind of is like the previous problem. Root 5 minus 1, root 5 plus 1. Multiply these, I get a 5 here. This is a negative root 5. This is a positive root 5. This is negative 1 times 1 is a negative 1. These are going to just cancel each other out. Conjugates always cancel out that radical term in the middle. So because of that, I can now just take 5 and negative 1 and combine those together. So my new numerator is going to be 5 minus 1 is 4. But my denominator does need to multiply out the 2. So it's going to be 2 root 5 plus 2. Notice that 2, 2, and 4 are all divisible by 2. So I can take all three numbers here, divide by 2. So that becomes radical 5 plus 1 all over 2. And that's it. Okay, so let's do one more. And again, we're looking for the conjugate in order to make this work a little bit better. So when I do this, I'm going to take 2 minus 2 root 3. And I need to do that to the numerator as well. So notice I'm going to be doing two sets of distributions here. So my first set, I would do my numerator, do my box-like method right here. That's 4 radical 2 and 5, and 2 and negative 2 radical 3. So I multiply together, I got 8 radical 2, 10, negative 8 radical 6, and then negative 10 radical 3. When I do the bottom part here, my denominator, do the same exact process. So I got 2 root 3, 2, and negative 2 root 3. So as a shortcut, all I really care about is these two and these two. So that's a negative 4 times 3, which gives me a negative 12. Okay. So these two, if I do go ahead and just do it, that's 4 radical 3 and negative 4 radical 3. So again, that because of that shortcut, I can just ignore those anyway, but that's what we get. So we combine these together here. So my numerator is going to be this. It's going to be 8 radical 2 minus 8 radical 6 minus 10 radical 3 plus 10 all over a negative 8. So in this scenario, I've got all my numbers here in front of the radicals. I can take these all and divide by a negative 2. So when I do that, my new expression is going to be let's see, it'll be a negative 4 radical 2 plus 4 radical 6 plus 5 radical 3 minus 5 all over 4. And that's as simple as I can get with that problem. Okay. And that is it for today. So we're just dealing with our radical properties. Just conjugates is a part of this as well. But just make sure that when you do your operations here, radical, like one of the big keys here is if I ever have to do like radical 2 times radical 2, it always just simplifies to 2 or whatever number it is. So radical 3 times radical 3 is 3. So we're just doing our multiplication and technically our division, but we simplify all those expressions that way. All right. And that's it for today. Take care, everyone.